Today we're going to wrap up chapter 3 by talking about rational numbers. A rational number is a number that can be written as a quotient, and remember that just means a division problem, of two integers where the divisor, okay, that's the number doing the dividing, the denominator, is not 0. So in general, everything that you are going to deal with is a rational number, okay? Examples are 2 over 5, that's a fraction, 0.46 repeating, that should have a decimal, 0.06, 3.5. Because you can write any integer as a quotient with a denominator of 1, all integers are rational numbers. So it's anything that you can write as a fraction, okay? So 5 you can write as 5 over 1, therefore it's a rational number. Now, let's talk about this statement down here because this is really important. It says you can write a negative rational number in 3 ways. That bubble was kind of big. And it could be negative 7 over 9, negative 7 over 9, or 7 over negative 9. So let's think about it with some numbers that we can actually divide out. So if I gave you negative 10 over 2, that's negative 5. 10 over negative 2, that's also negative 5. Okay, and what happens is when I give negative 10 over 2, people want to say, oh, that's negative 10 over negative 2, which would actually be positive 5. This is just suggesting that one of these numbers is negative. Okay, so down here it says compare negative 1/2 and negative 3/4. Okay, method 1 is using a number line, right? This is 0, this is negative 1. So this would be negative 1/2, negative 1/4, negative 3/4, or 3/4. So if we're going to compare negative 1/2, that would be right here. And negative 3/4, that's down here. Okay, it's just like when we're comparing integers. This is the smaller number, right? It's the bigger negative, it's the smaller number. So negative 1/2 would be larger than negative 3/4, right? Because it's more positive. Okay, the other way you can do it is using cross products. So if I have negative 1/2 and negative 3/4, remember we can do our cross products. 4 times negative 1 is negative 4. 2 times negative 3 is negative 6. Negative 4 is bigger than negative 6. You just have to remember if they're both negative, right, that your cross products are going to be negative. So like here, 6 times 2 is 12 and it's negative. 3 times 1 is 3 and it's negative. Negative 3 is bigger than negative 12. Over here, 8 times 1 is 8 and it's negative. 4 times 1 is 4 and it's negative. Negative 4 is greater than negative 8. 10 times 1 is 10 and it's negative. 5 times 3 is 15 and it's negative. Negative 10 is greater than negative 15. Then it says terminating and repeating decimals are rational numbers. You can also compare decimals using the signs of the numbers and the digits in which they differ. Okay, so which one is bigger, 4.4 or 4.7? 4.7 is greater. What about negative 4.4 and positive 4.7? If you're comparing a negative and a positive, the positive is always going to be greater. Okay, what about negative 4.4 and negative 4.7? Negative 4.4 is bigger, right? It's this smaller negative. Think of it like temperature. If it's negative 44 degrees or negative 47, negative 44 is warmer. So which one of these two, last two, would be bigger? Negative 4.2. Okay, now we're going to put some numbers in order. So the first thing that I'm going to look at, okay, I like to do the positives first. So I have positive 1/4 and positive 1.1. Okay, well I can tell automatically 1/4 is going to be less than 1.1, right? 1/4, I don't even have a whole pizza. 1.1, I have a whole pizza and part of another. Okay, so now I'm going to deal with these two negatives. I have negative 0.2 and then I have negative 2 over 9. Okay, so this is a 2 in the what place? This is a 2 in the tenths place. This is a 2 in the ninths place. So what we learned yesterday is that if it's in the, if you have the same numerator, the smaller denominator means the bigger number. So, but because this is negative, remember, this would be the bigger negative. So this would be the smallest number. -2/9, and -0.2. Okay, or use your cross products. -18, -20. This is the biggest negative, so it's the smallest number. Okay, let's look at the next one. I'm going to start again with my positives. That's always easier to kind of wrap my brain around. This is less than a whole pizza. This is 2 2/10 of a pizza. So 2/3 and then 2.2. Now I have to deal with these two negatives. Okay, just looking at it, if I were to think about it on a number line, right? If I have -0.1 and -5/8, right? If this is 0 and this is -1, -0.1 would be right here. -5/8 would be closer to -1 than 0. So I know -5/8 is going to be the smaller number. Okay, and then this last one, I have a whole bunch of positives, okay? So the first thing I need to do, I'm probably going to tip these two over and see what they are as decimals. So let's do 1/8 first. 1 divided by 8. 8 goes into 10 once. 1 times 8 is 8. Bring down to 0. 8 goes into 2 twice, or 8 goes into 20 twice. 2 times 8 is 16. And 8 goes into 40 5 times. Okay, and now I'm going to do the same thing with 1 divided by 32. I'm going to turn my paper over. 1. Okay, so 1 goes into, or 32 goes into 1, 0 times. 32 goes into 10, 0 times. 32 goes into 100, 3 times. 32 goes into 40 one time. Okay, I'm going to stop there because it's 0.031. So I want to see if that gives me enough information. 0.031, 1/8 I figured out is 0.125. Okay, so let's look. That gave me enough information to put my numbers in order. I'm going to do it down here. Okay, so I have 0.025. That's the smallest. Then 0.031, so that's 1/32. Then 0.125, and then 0.625. Oh, I should have written this as 1/8. And then I'm done.